Folks, welcome to the first lesson, which is the cast diagram. If you think you're okay with the cast diagram, please just watch the video because there's one or two examples that I think may get you thinking, and there are questions at the end that I want you to practice. Anyway, let's crack on. Let's get the job done. So that diagram explains what the cast diagram is all about. Between 0 and 90 degrees, all the trig ratios, sine, cos and tan, are positive. Then between 90 and 180 degrees, only the sine ratio is positive. Between 180 and 270 degrees, only the tan ratio is positive. And then between 270 and 360, only the cosine ratio is positive. So specifically, if we take examples, so for example, 70 degrees, which is in that first quadrant, we find the values of sine 70, cos 70 and tan 70, they are all positive values. If we go into the second quadrant and just pick an angle, 150 degrees, we find that only the sine of 150 is positive and cosine and tangent of 150 are both negative. In the third quadrant, if we randomly pick an angle 200 degrees, we can see that sine and cosine are negative and tan is the only positive ratio. And in the fourth quadrant, 320 degrees, we should expect only cosine to be positive here. And there we go. Sine and tan are both negative, but the cosine of 320 is positive. And that's what we mean by using the cast diagram. So let's see how we actually use a diagram. Here's example number 1. Express sine 120 degrees in terms of an acute angle. Well, there's 120 degrees on the cast diagram. And in that quadrant, only the sine is positive. So sine 120 degrees is positive. And in order to find the other angle that's equivalent in size to sine 120 degrees, you always measure to the horizontal axis. So it's that angle there, 60 degrees. So sine 120 degrees is equal in size to sine 60 degrees because that's the angle to the horizontal axis. Now, we know that sine 60 degrees is positive, and we've just seen, because we're in the second quadrant, that sine 120 is positive. Therefore, we simply have that sine 120 is exactly equal to sine 60. Here's a second example. 320 degrees. Let's find the angle first of all. There it is, 320 degrees. It's in the quadrant where only cosine is positive, so tan 320 degrees will be negative. Once again, we always measure to the horizontal axis, so from that angle there to the horizontal axis is 40 degrees. Now, tan 320 degrees is therefore equal in size to tan of 40 degrees. However, we know that tan 40 degrees will be positive, and we know, because we're in the blue quadrant, that tan of 320 degrees is negative. So although they're equal in size, one is positive and one is negative. So tan 320 is the negative of tan 40. Here we go with it, example 3. 250 degrees, let's find it on the diagram first of all. There it is, and in that quadrant only tangent is positive, so cosine 250 is going to be negative. What's the angle that's equivalent in size to 250 degrees? Well, we measure to the horizontal axis. It's that angle there, 70 degrees. We know cosine 70 degrees is positive. We can see, because we're in the yellow quadrant, that cosine 250 is going to be negative. So we write cosine 250 will be the negative of cosine 70. Here's example 4. Negative 50 degrees, the tan of negative 50 degrees. Well, first of all, we need to know what we mean by negative 50 degrees. And negative is measured in the clockwise direction. Therefore, negative 50 degrees will be 50 degrees measured clockwise, and that'll be actually 310 degrees. So tangent of 310 degrees will be negative. What is tan 310 degrees equal to? We measure to the horizontal axis, and it'll be equal in size to tan of 50 degrees. But we know tan of 50 degrees is going to be positive, so we can't say that tan 50 equals tan of 310. It's tan of negative 50, or tan 310 is the negative of tan 50 degrees. Here's example 5. Where is 580 degrees? Well, one full turn is 360 degrees. So cos of 580 is the same as cos of 220 degrees. And that's the same as negative cos 40 degrees. I hope you can work that one out. There's 220. There's 40 degrees to the horizontal axis. And we know in the yellow quadrant that cosine is negative. So cos of 580 is negative cos of 40 degrees. Here's example 6. We don't have an actual value, we've just got theta. So tan 180 minus theta. Well, first of all, there's 180 degrees. Then take away theta from that. Now, we don't know how big theta is, so I've just gone back a little bit, equivalent to an angle of theta. And I've gone back, theta would therefore have been that amount on the diagram. And therefore, 180 minus theta, we can see that that's theta to the horizontal axis. In the red quadrant, tan is negative, so tan of 180 minus theta will be negative tan theta. Here's example 7, sine of theta minus 360. Well, if we add or subtract 360 degrees from an angle, it doesn't change its value, and therefore the sine of theta minus 360 is just the same as the sine of theta. So that's your cast diagram. That's the exercise from the textbook. That's the Pure 1 textbook. I recommend you have a go at questions 4, 5 and 6. You really need to know how to use the cast diagram because it's going to occur in the section solving equations, and that is going to be tomorrow's lesson. So I hope it goes well. Just drop me an email if there's anything you're not sure about. I can tidy that up for you, and I'll speak with you tomorrow.